Okay, so hello and welcome to this third lecture of the third module. So, as you know, in this module we have talked about the transport policy, we also talked about the data. Now, we are trying to look at how the emission reduction and efficiency improvement can be done for the vehicles and what are the environmental perspective associated with that. So, that is what we are going to cover in this particular video, this particular module. This particular lecture of the third module, and the PDF associated PDF is also available. So, which you can refer to. So, okay, so let us get started. So, in terms of emissions, when we talk about, there are broadly we say three kind of broad categories of emissions: is scope 1, is scope 2, and is scope 3. Is scope 1 is the direct emissions that you are the company facilities or the company vehicles who, like if you are talking about a auto manufacturer company, auto manufacturing factory, say car manufacturing factory. So, what are the emissions that is happening within the plant itself? That's considered as a scope 1. So, the company will report that as part of the scope 1. Then is scope 2 is the indirect emissions, like whatever the fuel, energy related activities, purchased electricity, steam, heating, cooling, for whatever they use for in the plant boundary, within the plant boundary itself, that is indirect emissions. So, that is called as scope 2. Then scope 3 is also indirect, but the scope 3 is much broader. It kind of takes into consideration in the upstream activities. If you look at the upstream, scope 3 has both upstream as well as the downstream activities. So, it tries to capture the entire value chain, entire supply chain. So, you start from the purchase goods and services, whatever the capital goods, you have some transportation, waste generation as part of the operational process, business travels, employees commuting, leased assets. So, each and everything, as you can see in the upstream activities, things we try to capture each and every aspect. Similarly, in the downstream as well. So, after the product is made, when it comes out of the factory. So, transportation and distribution, processing of the sold products, when the product is being sold, how it is its use, like processing of that, use of that, end of life treatment of the sold product, leased assets if you are having a leasing certain stuff, franchises, investments. So, all those things that's and the downstream activities. So, upstream and the downstream activities try to capture the entire value chain. So, that becomes your scope 3, and then we have a scope 1 and a scope 2. Most of the scope 1 and scope 2 is more common. Scope 3 becomes quite broader, and a lot of things has to be taken into consideration, but that's that's the trend right now to kind of report all scope 1, 2 and 3 emissions. So, in terms of emissions, we are talking about like what are the emissions we are talking about? Carbon dioxide, methane, like CH4, N2O, HFCs, PFCs, SF6, NF6, NF3. So, these are, and then broad, there are many more. So, these are the broad categories of emissions that we are looking at. So, these are essentially, again, when we are talking about decarbonization, we have to reduce all these emissions factors. So, to reduce all these emission factors, emissions coming out, we need to actually measure where the emissions are coming from and which process is leading to more emissions. So, that is the hot spot that we talked about earlier, and how to reduce the emissions from those particular processes. So, that is what kind of more major focus. So, once we do that, then we can look at in terms of our in terms of your overall emissions efficiency of the, we will improve the overall emission efficiency of the vehicle. That is what basically our goal as that what we are talking about in this particular lecture, in this particular video. So, if you look at why we are talking about that. So, this if you look at the transportation sector, greenhouse gas emissions from the transportation sector, its CO2 emissions by if economy, if you look at around 20 electricity and heat production, which is 42%, nearly CO2 emissions from electricity and heat production itself is around 42. Then we have 22% in the transport sector. You have manufacturing and construction, that is 21%. Residential, like we have people living in houses, 6%, and then other categories is 9%. So, out of the transportation, if you take it further breakdown of that, we see that around our vehicles, like the high automobiles is like 40%. Automobiles, the cars that we typically use is a 40%. Trucks is 34%. Then aviation is around 11%. We have marine is around 11%. So aviation and marine is almost the same, and then 4% is in the railways. So that's what CO2 emissions by the different transport sector that we see as part of our activities that we are doing. So we do need this stuff, isn't it? So we do need to connect people. We cannot we need to build these kind of highways that you are seeing here. We need to have connectivity for people to move from one place to another place that is needed. We cannot avoid these kind of construction. In fact, we can make it more efficient, and we can make better use of these facilities. So, but we need to come up with these kind of infrastructure to sustain the population movement requirement, the population's day-to-day requirement of moving around, and even our goods to move around. So, for any economic activity, we need to create this kind of infrastructure. Or this is another example where all these kind of infrastructure is needed. Now, so those are needed, but how to avoid these kind of congestion. So, as you can see over here, we need to have a better, so that is also going to, in terms of the emissions, if as you saw in the previous stuff, not much traffic jam, traffic is just moving around, and then of course they will have emissions, but if you compare this with this one, our emissions are when the vehicle is stagnant, that it becomes vehicle is stagnant, creating all those emissions out there, and it becomes a problem. Like with traffic jam, every traffic jam leads to more emissions coming out. More breakage you need to do, like more you have to, if you move is nice and smooth, every vehicle has a certain kilometer per hour or miles per hour guidance, that if you drive on that, you have better fuel efficiency. But in cities like with the congestion that we have to, many times your leg is on the brake, and more you push the brake, more is also the vehicle the fuel consumption, and more is the emissions associated with that. So that's we need to do a better job than what we see over here, and this is the case in many parts of the world, not only in India, but other places as well. We see these conditions, especially those really go bad into the winter months, and we see all those emissions going out and creating a lot of nuisance. So we have to do better in terms of having better our emissions coming out from those. So it's a work in progress. It's a work in progress where it's a construction and maintenance site. So we are looking at phases of construction, like for if you are trying to come up with in any your emissions report. So in construction phase, we also any emissions you talk about. So you have construction where embodied carbon of materials and fuels, consumption of energy for transport for materials, labor. So all those there are every CO2 emissions there. There are direct emissions from machineries and movements of labor material during construction and maintenance phase. Indirect emissions from site offices, carbon sequestration potential gets lost there. So then we have the maintenance phase. So we have phases and parameters involved during construction and maintenance phases of the national highway. So, and of course, on the left hand on your left hand side, if you look at the production of material, like when you produce material from the raw material itself, mining of the raw material, transportation of the material, movement of labor. So all those needs to be built in when we are talking about overall carbon footprint. So that leads to how will you define system boundary. So if you look at a certain like a construction event happening, how you define the system boundary, that's very, very important. So with global, like if you're talking about a road construction, where you should end, you should start from very like raw material acquisition all the way to the construction of the road, and all the emissions associated with that. So for example, if you look at here, they are looking about the stone, crude oil, those are the raw material, limestone, clay, iron, gypsum, and those then if you have some existing pavements, you're looking at reclaimed asphalt pavement as well. So you mill that. All these comes in here, your mining, blasting, crushing, extraction, refining, that you got the crust aggregate, bitumen, formed asphalt from then cement, and then you form the asphalt from there. Then you have cement coming from the raw material, reclaimed asphalt pavement, you kind of goes mix it with that. So, you have some hot mix and cold mix, you hot mix asphalt concrete, form asphalt cold mix concrete, paving, compacting, cooling down, curing, and then once the road is ready, that becomes open to public. So, if you look at the dotted line all across, that becomes your system boundary, all the system boundary. Within this, whatever is the emissions happening, we would like to capture. So, that is you need to be very careful when you are looking at these system boundaries as part of your any LCA report, because you can move around the system boundary and make look something which is not that great as slightly better, because you do not include certain aspects of it. So, that is very, very important, and then you have to make certain assumptions. Typically 100 kilometer lead distance is assumed for construction material. Then you look at 25-ton vehicles with 4.4 kilometer per liter fuel efficiency, density of compacted different bases, how much cement, how much fuel consumption, what are the following, what are the factors considered: electricity consumptions, diesel consumption, petrol consumption, others, consumption of kerosene, LPG, natural gas, biomass based fuel. All those things you need to make a list of all the assumptions that you are making, and then you come up with your life cycle inventory. This we talked about earlier many times as well, as per the ISO 14044, which has kind of taken all the 14, 41, 42, 43, they are all now merged together in ISO 14044, and this was earlier ISO 14041. So, you have your goal and scope, like what, as we were talking about in the previous slides, what is the goal of this LCA? What is this? Try to come up with how much is the carbon footprint of making, say, 1 kilometer of highway. 1 kilometer 6-lane highway, what is the carbon footprint? Look at the different processes which is creating, how much is contribution from the different processes of construction. So, that could be your goal and scope, and then based on that you prepared for data collection. You try to collect all the data based on the system boundary that we talked about. You collect all the data. Data collection is one of the most time consuming part, and then you have to also validate the data, make sure the data collected is correct. Then you relate the data to unit process, and whatever, say if you take 1 kilometer, when I say data may not be available for 1 kilometer. So, you relate that data to unit process, different unit processes like making hot mix asphalt, low mix like a cold mix asphalt, then making it in terms of your like about different activities that needs to be do, sub-base coats, base coats, all those you could get data for each and every unit processes, and then relate the data to functional unit. That's functional unit is 1 kilometer of 6-lane highway. Then get all the data collected and if the data is not available, you may have to refine the system boundary. Then this is the simplified, this is how we go into making our inventory analysis. So, once we have this inventory analysis, we kind of looked at different stages of like the emissions from the different stages. So, this is the carbon footprint of road and sources of carbon dioxide emissions. So, if you look at the road life cycle stage, one is the construction, then we have the road operation as well, and road maintenance. So, during construction we have construction material embodied energy that we are kind of releasing that in road operation, of course, that will not come in picture, and maintenance again that will you will get some of the newer construction material added to it. We get fossil fuel that is used, embodied carbon there as well. Then there is emissions, direct CO2 emissions associated with fossil fuel. Removal of vegetation, if you have to remove the vegetation from their carbon sequestration potential lost, and also direct CO2 emissions for during road construction. If you are taking some of this vegetation out, the process to take the vegetation out also has carbon footprint. Then machineries, all the machineries that will go into making your making your in terms of getting how much carbon footprint is associated with making of the machines, like when you are looking at embodied carbon. Usually we do not consider it as part of our LCA study, because those machines can be used for many years, but there is a carbon contribution, carbon emissions contributions from those machineries and vehicles, which is used as part of the construction activity. So, at the bottom, as you can see over here, I have listed one like ADB's website where they have the estimating carbon footprint for road construction. So, it is a good document, not too long, and I would encourage you to have a look at that, and that might be handy for you to have a and then we'll try to put that in our as part of the PDF there as well. So that you have the inventory database, you can come up with your inventory database like construction phase. You look at all the different, like how much CO2 sources, electricity, diesel, fuel wood, mostly diesel, bitumen and all that at different units. Then emission factors are also there. Then operation phase, we get similar data for the operation phase. Then you have the inventory, combine it together to get your CO2 sources, as long as in the maintenance phase you get those values as well. And then you try to in terms of, this is from the case study which was done as part of this ADB project, where they have come up with all these. You can see all those numbers now: electricity purchased, how much kilowatt hour per kilometer, and diesel used on, like diesel used in generators on site, per furnace oil used, how much trees got removed. So those you can see as part of these data which they have used. So per kilometer, how much electricity was required and all that, and diesel and other things were required there as well. So it's as you can see that there are a variety of data based on the site location and the site conditions. So then your construction material, how much construction material, aggregate, cement, bitumen, steel reinforcement, emulsions, how much they are being used, metric ton per kilometer, because all of them will have carbon footprint associated with that. Total diesel used for transportation of carbon material depending on the transport distance where they are. Traffic estimate for total operational phase, you look at how much light LCV, which is light commercial vehicle, then your bus, car, jeep, taxi, two wheelers, auto rickshaw, truck, tractor, and all those, how much total like a vehicle movement that you see over there. So those traffic estimate. Then how much is the modal share in terms of truck, tractor, LCV and all that, what is the share among the different types of vehicles being used on the road. Then construction material and fuels in maintenance phase, how much is being used in the maintenance phase. So all those data is kind of available. Then based on that you come up with your life cycle impact assessment, which is the total CO2 emissions is the material usage, fuel usage, transport of material, labor, fuel, etc. And you can look at these like how much you can look at this equation, and that is how it has been calculated. So as has been told earlier as well, this LCA is nothing but a environmental accounting exercise. As you can see over here, it is essentially like an accounting. You are trying to account all the carbon which is being used in different stages, different scenarios, and you bring them together, and then you get your total CO2 emissions coming out. So based on that you get your in terms of time period, different time period, how much based on road length, how much of CO2 is getting released. So you get those numbers, and as you can see that and based on those numbers you can make some decision. Based on these numbers you can make some decision in terms of what needs to be done for the different like in terms of why for if you look at this per ton kilometer in those national highway for MP, and that one had a highest like a carbon emissions ton per kilometer, as opposed to what we see the rural road in West Bengal. And so first one is the national highway, so that's why you see the most. Then we have a state highway in Madhya Pradesh as well as in Uttarakhand, but Madhya Pradesh is state highway, it's a like a multi-lane, and then the state highway in Uttarakhand is narrow one. So that's why you see the difference in terms of CO2 emissions. And then rural road in West Bengal, as you can see, has of course the lowest emissions right there. So this is again looking at when you do this LCA, you kind of when you get all these emissions data, goal and scope, inventory, then you identify significant issues. Do you see, like for example, at some places we see much higher carbon footprint as other places. What is the reason? Is it just because of the lane width is more, or it is some other causes there too? So what are the other causes? Look at the sensitivity check, consistency check, completeness check, and then come up with the conclusions, recommendation and reporting on how we can reduce the carbon footprint, as much as possible. And then you can direct application where you can use this data, you can use this information for product development, public policy, marketing, and including trying to reduce the emissions from the vehicles on the road, especially for the road transport in any country. So that's what we have in this, and I would just quickly also show you this ADB report, just which and so that you, and I will have it we will have it available. It is available on this particular website. So just give me a second. I will just open that ADB report so that you can have a look at that as well. I'll just and I will post this PDF, so you can look this. You can look at this PDF while you can download. We will download and put this up in the website. So let me just get that. Give me a second. So this is the document I'm talking about. So this is let's download it on the desktop right here. So let's go back. Yeah. So as you can see over here, so this is the document we have, and now methodology for estimating carbon footprints for the road project in the case study for India. This was done by the Asian Development Bank. So most of the stuff that you saw as part of this particular video actually came from this document, where it talks about understanding the carbon footprint of the road sector, how the methodology, how estimating carbon footprint for selected ADB funded roads in India. So road construction phase, operation phase, maintenance phase, how to estimate the carbon footprint of total ADB road portfolio. So this is just an example. Of course, Asian Development Bank has come up with this document, which could be you can use for personal and non-commercial use. It is, as we have given reference in the slides also, we have properly referenced to this report. And then we are going to put this report on our website as well. And so if you can, if you want to learn more about that, you can always look at it. It's only 30 some pages document. Okay, so that's it in this particular video. In this particular video, so thank you, and we will again do the next video, and then we will see you in the next video.